Hello everyone, am I audible? Please let me know. Hello Himel. We will be starting our session shortly. Sorry for the delay. Now that I want to start today with some hands-on. To catch up the previous day, we saw what is a NumPy library and how we can declare certain arrays and operations, but I felt like it wasn't enough. So at first we are going to see some of the codes, then we are going to know about the vector that was supposed to be known today, and we are going to know about vector which will be introductory part, so that we can catch up later with the code where we can understand how it is represented in the code as well. So I'm sharing my screen. Wait a minute. As you can see, let's start from the very beginning. We will be exploring the data set or a data to uh, express our curiosity with Python here. So I'm assuming that you understand some syntax of Python, so that you do not feel a little bit unfamiliar. So let's start by taking an example. So we have certain data variable in a list format. We can see that it is in a list format because it is enclosed by a third bracket and there is comma. But how we can differentiate a list and an array, we'll surely see that in near future. Right now that I want to see this value, I will show you again. So if I want to see this value, I will simply run in the Colab file, which is similar with Jupyter Notebook, if you are familiar with that. If you are not familiar, it is one kind of notebook where we can helps us to run code in such short cell and textual description, so that we can understand with better understanding. So as you can see, after I hit run here by this certain small cell, we are seeing the output of the data variable, which is giving us a variable amount of 10 plus something data. So now we want to see this list in form of an array. So what we did yesterday, sorry, not yesterday, in our previous session, we took an help of NumPy array. So NumPy array is basically helping us to represent this array, because if we deal with larger data set, they will be similar like multiple list, and if you want to represent that in a environment, then it will help you to reduce the computational time, so that we can uh, create a relationship between the inputs and the outputs. So let's see what we would get if we hit run. So here we can see there are three lines of code here. We are basically in the first line here. We are importing NumPy, and we are importing NumPy as NP as a short form, so that while we are writing this NP multiple times or calling NumPy, so it could be a easy call, so that we can talk about it. So here we can see that we have a new variable where we can see that I am assigning that np. I am calling the numpy with this built-in function array and passing the list that we run previously. Here we saw that here is a list. So I'm passing the list here. So it will convert this list into an array. So how do I know it's an array? Because we can say there is a small thing, you will notice there is no comma in between them. So that is one kind of common understanding at a glance. But if you want to see through a built-in function for numpy that is d type, so we can also see that. We'll see that surely few moments now. So now that we want to see, as I said, we can check the data type. So now I'm showing you how you can differentiate the list and a numpy array. So for the third cell, we can see that I am calling print function, and inside that print function I'm another function here, type function, which is also a built-in function of Python. So I am assigning that type function with data. As you can see when I am hovering here, wait a moment. Uh, you can see there are the data that I have passed, which is a list, and it is saying that the list has 22 items in between. So, and I want to multiply all of these entries by 2. So, we'll see something interesting. What happens in case if I multiply a list by 2, and what happens in case of an array if we multiply it by 2. So, let's see what is the difference and if you can catch it as well. As you can see, it is saying that the class, which is an built-in information given, so the Python knows that the data type that you are assigning is a list, and this class list is kind of a blueprint embedded inside of the Python so that he can understand what he is dealing with. So we can see that we asked the Python with the help of uh, print and time function to multiply it by 2. Now as you can see that in case of a list, all of the entries are doubled. Basically the list here is repeated again. If I say if it is like a concatenation, let me show here. It's basically this list, then again, it- sorry, this, then again, same list, it is repeating. Let me change the color so that you can understand. So as you can see, it is basically multiplying the list by 2. It's elongating its length by 2. But in case of array, it is a bit different. We can see that wait, if I let me check if I'm showing the right window. Yes, I'm showing the right window. So okay, so as you can see previously, as I said, when I am multiplying a list, it is basically repeating another way. It is copying the list wholly and adding it at the very end. But in case of array, you would see that the value that I wanted is to be 50 into 2, then 100. So it is giving me that value. So in case of a list, we won't get such values. Instead of an array, we would get our desired output. That was to multiply all the entries inside them by 2, which is a very advantage for a numpy array. So basically they are built for this purpose. Now that we know a fun fact between an array and a list, now moving on to more generic stuff, which was previously we saw how we can check a shape of an array. So I'm repeating here and showing. So if I have a variable assigned previously, here you saw I passed an variable np dot array data, and the data was this list. So I want to see what is shape in array format. So I will simply write grapes dot shape and then run it and see its shape. You can see, as you can recall previously, it said that the list contained 22 items and it is one dimensional because there is only one row of values and there is no another entity. So that's why it is empty on the right side, only just comma 22 comma. If you are dealing with 2D, then you would have another additional value on the right and it would look something like a tuple. So it is already in tuple, but it would look like a coordinate if you want to visualize. Now that I want to see, we have already confirmed that it is one dimensional and it has 22 elements. Now we can see if the position here, so we can see what was the value of the zeroth item here, which was 50. As you can see, the very first value was 50, which which verifies our findings, and we can also find um, mean with the help of the built-in function. Simply grades and call the mean. We do not need to pass anything. So that is one thing. And so now that we have another example, so let's start with another example where I am going to define an array of study hours, and we are going to pass two quantities here, previously grades and study hours, so that we can visualize what it would look for a 2D array. So you can see that it is an 2D array because we are passing two different quantities here, and if we want to see what it looks to display, we would simply write the variable name here. So you can see that here is one input and here is another input grade. Now that we want to see whether it is definitely 2D or 1D to cross check, we can simply recall the function's shape here. As you can see, you can there is 2 comma 22, so we can verify that it is indeed a 2D array and it is showing the shape. And so this is how you can verify whether you are dealing with an 2D array. And you can also similarly check in case of see element of the second array here, which is 2D. So we can similarly use this index position which would be 00, this value. So let's see whether we get it or not. As you can see, we got 10, which is the initially the past value here. So now we have little bit understand the common function that we talked about in previous session. We can also get to know the mean of individual student data here. We can also do average of it. This is more advanced example, but I don't want to show it right now, but I want to show you the array math operation. So let's say I have two array, 3 2 3. Let me add one more. Let's see, now I want to add, it is similar like the addition that we perform, so it would result as same things that we do it by hand, but it is like simplifying it here and faster response. We can simply assign them here with the variable here and print this. We do not need another additional built-in function to declare here. We can simply add the variable array1 array2 minus, which is very simple here because we are dealing with 1D array, but in case of 2D array, it would result the same, but it would look different. Now that we are done, but I wanted to show the matrix that we dealt previously in day one, that we can also represent them with matplot and with the help of NumPy. Matplot is basically helping us to plot those, but I want to show you pandas. But before that, let's dive into the vector part, because which is our uh, main topic for today. Okay, I'm showing you the right slide. So as far we know that vector is a something that consists of magnitude and a direction. But in case we are curious how the word vector came, so vector is kind of a Latin word, vector. mm, okay, vector. So it is a one kind of Latin word, and which means to meaning is to carry something, is to carry or act as an carrier of a data or something. So in physics, we understood the vector is something that has magnitude plus direction. So if you were to ask to give an example of a vector, you would be like, what is that? But we previously dealt with such quantities before. We saw a metric representation, which was row matrix, which is also a example of a vector. Then also a column vector. Um, these are also a representation of vector, but if you want to see in plain sight, then it would something look like in format. It would look like this. It's very straight line, I know. So now it is a vector because it is carrying an information from A point to B point, and its value from A to B is giving us a value, so which is the distance between them, and this distance is denoted as magnitude. And the pointy head here is known as head, and the leading tail is known as tail, as its name. So we can understand where is the starting point and the ending point of an array. Sorry, not an array, of a vector. So vectors have many application in case of physics, engineering, and all. So why are we learning this vector, if you ask? So let's say uh, I am starting with an example. I have a good network. Does it look like a network? It does not look like a network. Wait, it looks like a bacteria. Sorry. So let's say this one, this one, something that we are all familiar with, a topology. So this one is a very good network, and this one is a bad network. I'm I'm making it sus so that it would look weird because topologies in general do not look like this. So sus network. So how would I know if this is a sus network and how this is a good network? So if I know the basic operation, which we will know, dot product, we'll see what is dot product. But I want to show you why we are going to learn this and what is its application. So we will start with a very short example, and so that you can understand, because sometimes we just know how to calculate a certain value, then it be like it is just mathematics and I'm bored. So I'd rather start with an example then learn about it, why I'm learning. So I'm learning the thing dot product because if I were asked to make a judgment whether which network is good or not, here I'm basically assigned here. I know as I draw here, this one is SAS, this one is good, but in case I didn't know, in case let's say I didn't know which one is good, which one is bad, and I have A and B network, so how would I make an analysis or do sorting, things like that? So what I would do is we would operate vector dot product here. So as you know, the vectors have direction and magnitude. As you saw here, we have a direction and a certain magnitude. Here everyone has a direction and certain magnitude, and they are connected through them. And here also same goes for here. So if I did a dot product here, a dot b, and its output, if its output is something positive, what would I get? And if I get something zero, what would its be answer? And for negative, what would be? Oh, sorry. So these three scenarios are giving us some certain ideas. For certain scenario one, if I begin with the first scenario here, oh, if I start with the first scenario here, we can see that we can make an understanding that whether we conduct a test, medical test, and if we are diagnosed with a certain disease, so its result would something end up positive. So we are performing this dot product with a good network and a SAS network. So if our output is positive, then we can come to a conclusion that the network that we are dealing with B is not a good network. So we will take precaution. And if our output is zero, for in case of second scenario, we would say that it is nothing suspicious and it is okay. So that is one of the idea, or we can make judgment that we can make. So similarly, if the dot product is negative, we can also suggest that the suspicious or the sus network is nearby but in opposite direction of the network. So it is also indicating a threat. Both positive and negative output here is giving us an idea that we are encountering with a positive suspect, but its direction is giving us an idea. So if the direction or the output is positive, so it is saying that the potential threat needs to be further investigated. But in case we get a negative value, then we need to be cautious that the network is here but in opposite direction. So applying this dot product in a concepts in a such way is very essential if you want to work in cyber security or in neural network kind of work. In ML, there are neural networks. We have to deal with multiple very compact data set. Neural network is very smart and most effective. So if you are curious to know about neural network, it is very essential that you have a grasp understanding of vector. Otherwise, you would not be able to understand what is a neural network and how they are operating, as multiple networks are interconnected with each other. So now that we know a certain purpose why we are learning dot product, now let's know something that we will know more about a vector. So now, until now, we know that vector is something that has direction and it has a uh, direction and a magnitude. Let's say we are curious to know more properties of vectors. So let me. So now that we are here, we are going to know about some rules that vectors obey. So the very first rule would be number one: a vector must have a magnitude and wait a minute. Yes, my screen is okay. and direction. Number two, the number 2 point would be that we can simply add two or more homogeneous homogeneous vectors, but there isn't but we cannot add different kinds if they must be similar in nature. Let me see. Let me minimize. Now moving on to the third point, that would be like if I was asked to multiply uh, two vectors, if I asked to do a vector product of two vectors, what would be the resulting value? The vector product of two vector would be a vector quantity. And similarly, scalar product, the other name of dot product is scalar product. So dot product or scalar product, whatever it is, same thing, of two vector is a scalar, because you can simply understand by its name. So uh, no, I'm sorry for my bad handwriting, but please do let me know if you do not understand any sort of handwritings. And they follow the rules of additive and distribution that we are all familiar with. So if it is like a plus bc, the value would be like a plus b, a plus c. And one fun thing I forgot to show is the vector notation. We there are various kinds of vector notation, but if I want to give here, let's not give it here. Where I will show the vector notation in another place. So if I want to show this certain vector in its original representation of or official notation of it, so I would simply write something like AB and an arrow sign, so we can understand the starting point is A and the ending point is B. And if I want to figure out the magnitude here, so I would simply write uh, wait a moment, the distance of A and B here would look like AB prime. So which is saying that it is giving a scalar value. Now let's show you something. Hmm, think between A and B. I want to show you something, but let me check first. So yeah, so I will show you the example of magnitude with an example, but because it is very arbitrary here, I'm not showing right now. So before we go to the vector, let's know some example. What are the quantities that are vectors and what they are not. So if we want to know what is a vector quantity, something that must have a direction and a magnitude, and the special vectors that we are learning from the day one in our physics journey, that would be like force. Okay. So what do you everyone know what is the definition of force? If you know, please let me know in the comment section. Let's see. Um, I'll wait for a moment. Mm, so now, as we are getting some responses, so force is something that is causing a change or causing a body in a state to change its force of motion. So if a body is in rest, it would stay in rest unless a force is not applied. So if I apply a force F, then it would go forward basically with a certain direction. If the force have certain magnitude 1, then if I want to know what is the acceleration of the body here moving, the equation would simply look like sort of this force by F by m, and we can also know the value of the force by FMA, a very popular equation if you are studying physics. So as you can see, I have given arrow notation in case of A, which is acceleration and force. Why have I done that? Because both force and acceleration has a direction, but in case of m, here the m is mass. So mass of the body, let's say it is an a object. So it does not have certain direction or something, but it do have a weight. So it, the weight here is acting like a magnitude here. So we cannot say that the vector m is a vector because it is a scalar quantity, and it must be a scalar quantity because it do not give us a certain direction of its motion. So we cannot say that it is a vector. And moving on to the acceleration part, it is giving us an idea how fast and slow the body is moving, and it has a certain direction. So we can say that it is a vector. So if we cannot come to a conclusion that if whether if a certain quantity is vector or not, we have to check two things. That would be sorry. checking condition checking condition wait a moment checking condition it must have direction, which is a very red alert type of indication whether a certain quantity is vector or not. So now that we are kind of familiar with an idea what is a vector or an introductory part, let's know about a unique vector, which would be a unit vector. And unit vector is something a bit different because we can understand by from its name that it must be something in unit or something in one. The value of it must be in one. So that is kind of the deal here. Let me let me go to a clean space. Okay, I'm in right space. I'm kind of little bit. So, if you want to know official definition of what is a unit vector, that would be something like when a vector is has a direction and magnitude, and its magnitude must be an unit, and unit must be the unit value must be one. Otherwise, you cannot say it is a unit vector because we are going to use this unit vector as a reference point in certain places. So it must be a certain value 1. So let's say I have a vector. Let me bring straight line. We have a axis x and y. Uh, do not okay. It is not perfect. Sorry for the. Mm, it is bit curved. Wait a minute, sorry for the. So now it is straight, a little bit straight. We can work with that. Mm. Now let's say I have a vector. Let's assume that this value is 1 by 5 and this value is kind of 3 by 4. Now that I want to draw a line here, wait a minute. Let me see whether I am in right slide or not. Need to cross check something. So let's, sorry for the pause. Mm, so if I want to show you an example, I'm not getting a good example here. Let's take an arbitrary example. But as I have drawn an axis, let's say I want to find the magnitude or the distance between certain two vectors here, I would simply write, I'll first connect this two line. It is a bit curved, but it should be straight. And let's say I have a vector A and B is something like 3 minus 1 plus 4 minus 5 whole square, then root over. There will be something like that, but I'm not showing you the value. It would be a something certain value. So moving on to the unit vector. So let's say I have a straight line and I'm going to divide this into four equal parts. So let's say this one is a, this one is a, this one is a, this one is a, and my overall, this one is a, this one is a, and my overall vector, let's say A, is 4A. 4A, and if I am going to show a certain value of unit vector, then the notation would something look like this with a small arrow on the top. So it is the normal notation of a unit vector. If you are dealing with, we have to write it with a small arrow or half triangle format so that we can understand we are dealing with an array, sorry, a vector here. So how we can know that it is a unit vector? Let we are considering that the magnitude of it would not be 0, and we have a direction unit vector which is along the direction of A, which is PQ, let's say PQ, and the unit value of this from this end to this end would be a vector, would something look like this, and we would simply represent as A, A and hat sign. So now that we know that we have divided this part into four equal parts, its magnitude would be something like 4 units. So, and if the unit vector along this along this PQ or direction of A is A prime, then our all of our value would be of A, which is we previously wrote 4A, 4A prime, and if we want to uh, deduce a formula of it to know whether it's a unit vector or not, we will simply write unit vector, the vector and the magnitude value under it, and it would something look like this. So this is how we can figure out a unit vector of a certain value. So this was one kind of example of it, and now that we are going to move forward with something a little bit new thing, that would be let's say, hmm, the types. So let's say uh, with the easy one, let's start with the easy one. We have now understood the unit vector. Let's start. Oh, I missed this section again, the alignment issue again. So let me go over this again. So if I have a vector A or a certain vector PQ and I'm going to divide it by four section, and I'm assuming this one unit as a vector A, unit vector A with an hat sign. So assuming that, so if I want to know the overall whole value of this vector and naming it A, then the value would look like 4A, as because we know we divided it into four equal parts and four units. So the unit vector along this PQ or direction of A is A prime. So the answer would be like this, and we can deduce a unit vector by putting a vector, its original vector at the top, and dividing it by the magnitude of it. So now that we know what is an unit vector, let's move on to another one, which would be a fun one. We can already know what it is: equal vector. So if I have vector A, as we are saying it is an equal vector, then the direction and the magnitude also would be something similar to A. But if I have a vector, third vector C, but it is not equivalent to its magnitude A, but we cannot name it or say it is a equal vector. But in case I want to show that it is equal but in different direction, let's say I have a different vector, it is equal in length similar to A but in different direction, then this vector would be opposite vector. And if I want to show another direction, it would be like this. Similarly, everything is opposite vector. If I draw another one here in the opposite direction here, sorry, wait a moment. Sorry, I had to cough. So now that we are familiar with certain vectors, let's do a certain example. So let's say, hmm, let me get an example. Let me find open space. Let me remove my headset for a moment. And let me know if you can still hear me. So let's do an example. Example 01, and we have a coordinate PQ, P within certain value. Let's say our P is a vector R1, row vector, or a row matrix if you want to visualize it. So let's say it has a direction I plus 4 plus j plus 5k. Now that you must be a little bit confused why I wrote something like this. So as you can see, they look similar in to unit vector, but why it is ijk? So we have three axes in our that we deal normally in case of doing math in calculation. So It is not straight, but for the sake of understanding, it is the y-axis. This is the x-axis, and this one is the z-axis. So if we are dealing with something three variables or three dimensional, so the value would something be like sorry, not so value would something look like let me the I vector is here, the y vector is indicating the j vector, j unit vector, and the k vector is denoting the j vector is denoting the k vector. So these three unit vectors are represented in three different directions. So I, j, k. They have their own unit vector representation. That's why I wrote it like this. So as we are dealing with three coordinate system here, x and y and z, three different axes. So we are going to, now that we understand that, we can visualize this vector, this pq vector in this direction. So let's say if I want to plot this one in this very axis, let me draw it in a good way. Now it is still not good. Let's roll anyway. So now that I want to plot this, let's say 3 minus j. So minus j. Oh, no, so minus 3i, minus 3i, sorry. So as I want to plot this, that would something like minus 3i. Minus 3i would be something like here. And the vector, another one, 4j. 4j in the positive direction. It would look like this. This one is 4, this one is minus 3. 4j minus 3i, and the z1, the third axis, whose value was, I forgot, 5. The value would something go here. So the combining, if I want to join these three points, then we would visually get an idea of a certain vector pq here, and we can grasp the position for an for the sake of understanding. But if you want to see this in desmos, then you can simply try, but I'm not showing you right now. But I want to show you an example how we can conduct a magnitude by simply saying a certain vector, because previously we did with the help of certain coordinate. So now that we understand its representation in the Cartesian system, let's move back to here. So 3i minus 2j plus 4k. Do not forget to give the cap sign here. So let me see if my screen is in the right place or not. Oh, it is not showing. Can you see now fully? Let me see. Can you see it now? Let me know. So it is something looking like this. As I said previously, let me show it again. Begin issue. So we can visualize mm, this certain vector here like this. We can visualize this if we connect this three, or we can also individually say this as a existence. It would something look like this. And now that we understood the purpose of ijk, the individual unit vector represented by the three respective axes. For x-axis there is I unit vector, for y-axis there is j unit vector. And you must be mindful, as you see I have not given the hack notation here, which is a very deal breaker here. We would not understand whether it is a unit vector or not. We must be mindful, we must give the head sign here. Now that we want to see this in action, let's see them in action. So let's say if I want to figure out the magnitude here, so what would I do? Previously we did simple subtraction. So at first we would previously saw that I said that if I want to figure out a distance between certain a and b, I would simply deduct the value, then I would do the magnitude operation. In previous slide was not very elaborate about it, so I'm going to show now. Step 01, I would firstly subtract the value here. Wait a moment. So now that we are starting now, sorry, now I, as you said, I said that I have to find the distance between them. So the PQ value would be like R2 vector minus R1. These two position vectors we have to subtract. So we will subtract them at first. So the value would be something like 3 minus 3 would be 6 I plus, am I showing the right? Yes, I'm showing the right. Okay, I'm showing you the right screen and the right things. Nothing could possibly go wrong now. Then minus 4 j, then the third vector, that would be like 4 minus 5 and k. The resulting output would be like 6i minus 6j minus 4k, which is also vector. So if I want to do this similar operation in case of addition, I would simply to follow this procedure. So let's say I'm going to show it later. Let's stay here for now. I'm going to show that later on after I finish with this one. So now that we have a idea what is the distance between PQ, which is also a resultant vector. So now we want to know its magnitude and how we can come to an conclusion, how we can figure it out. So we have to figure out by simply doing square root. We have to square each of the entities here. So I would like and square root them. So the value would be something like 6 square plus, you must write here, minus 6. for the sake of understanding, I know that if we square a minus term here, it would simply cancel out. It would result in a positive value. But for the sake of understanding, I'm writing it here and simply square root the whole thing. Then we would simply get something like wait, something value of 73. So which is representing the magnitude value of PQ here. And if I want to know that whether it is a vector or not, as we can verify it does have a direction. We can see that it is represented by a unit vector and a certain value. We can also figure out its direction, but we are not going to know about it today. But if I want to show you something that I was telling that, let's say I have something like, I want to show you a generic definition of the summation and the division one, addition one. But if I were asked to do a multiplication of the values, then it would simply look like this. So wait a moment. So oh, so if I want to show you a generic definition or how to be careful of while doing such addition, we have to be very careful. Let's say I have a vector r1 r2 to the power rn a, a vector consisting of these values, and a p vector consisting of similar like r1 r2 rn. We must be very careful while doing such addition and subtraction of such quantities so that we do not get confused. So if I were to ask to do the addition here, so I would simply be like, let's give a different variable because otherwise we won't understand. So let's say, mm, V would be like not so generic. Say let's S1, S2, Sn. So let's say we want to add A plus B. The value would be something like R1 plus S1 plus, not plus here, that is the mistake we most of us do. Then we would simply add the second one. We would not do add all of them. We would add the separate quantities S2 and for Sn plus Rn. We would simply do and would get a certain value. Do not like add here. You would simply get a rounded value which is not a vector. we have to be careful of that. We will uh, end up with certain number of, if I have three quantities here, the resulting output of the vector must be in vector of 3. We must be very careful that whether while adding the terms, the summation must not be in one sum all over. There would be separate three values for the separate axis. So now that we are aware of the addition one, similarly goes for the third. Sorry, for similarly goes for the subtraction. And if I want to show you a short operation, which is the scalar operation, let's say I have a vector v 3 comma 2 and I want to multiply the value by a scalar 2, then the resulting output or the resulting vector must look like uh, 6 4. So generally if I want to see it in action, let's say initially it looked like this 3 comma 2 3 comma 2. Then after multiplying it by 2, the length extended by double, and the new one is like 6 by 4. So it would visually look like something like this. So now that we have now a short idea of what the addition scalar, now let's understand what is the dot product that we heard about at the very beginning. So let's say we have a row matrix. I'm going to explain it with a matrix because we are familiar with the matrix. So and is multiplication. Let's say we have one. Should we do 1, 2, 3, or let's not do 1, 2, 3. Let's do 2, 4, 1, and another vector 3, 5, 2. Now, if you can remember, when we were doing the multiplication in case of a matrix, we would select this row and multiply with this one and write the value here. So the very first condition of the matrix was to check whether the order is same or not. The first matrix row and the second matrix column. We have to check of the this condition. The first matrix and the first second matrix one, the row and column condition, so that we can do the condition is satisfying, so we can perform this multiplication. So the multiplication of something result in 2 into 3, 4 into 5, 1 into 2. So our resulting matrix is like this. So the value would be like 6, 20, and 18. But we should not write them like this because it is not the right order. So what would be the right order? Can anyone tell why it is wrong? That can be explained. Can anyone say that why it is wrong? Before I am saying that. So as we were dealing with the order here, we must be careful that the resulting output would result like this. So it would look like 3 plus 4 into 5 plus, or it is like something wrong. Can anyone tell? Let me see in the comments. As no one is telling, but the thing is here, the notation that we are going to do here is simply the matrix operation here. So we are going to perform matrix multiplication and we would get something a value of 28 here. So I'm not going to show you the multiplication here because we know that the multiplication how it works. So we that is a homework for you guys. So I'm not going to show you. It would be like repeating the same thing that previous day. So I'm not elaborating. So I kind of checked whether you have the understanding of the matrix multiplication or not. That now that we have a certain value here, what is this value giving as an idea? So this certain operation or these certain two vectors are giving us an dot product. This matrix multiplication here, A and B, is giving us a value which is the dotted product value of A dot B. So we can also write this thing as mm, in another form. So if I want to write it in matrix or vector form, like uh, let's say 2i plus 4j plus 1k, p 3i plus 5i 5j plus 2k. So if I represented these two matrices like this, then the what would the dot multiplication would look like, right? So we know that if we have two quantities of similar I and I and multiply them like dot product, then the resulting output would be 1. So here we would simply do the same thing. So if I want to multiply these two values, let me check something. And it is okay. I just cross checked whether the dot multiplication of I or I dot I is 1 or not, just because I was a little bit skeptical. And if we multiply two different unit vectors, then the resulting output would be 0. So as we are multiplying two same quantities here, the value of A dot B would something look like 3 into 2 plus 4 into 5 plus 2 into 1, and we are not writing the unit vector because I dot I is simply 1 and j dot j is simply 1, so I'm not writing that. So the resulting output would look like 20 plus 2, which is also 28. So we can also represent this uh, dot product in this row column matrix and also this vector positional vector representation. We can also do a normal matrix multiplication and get such values, and a new representation of getting a value which is our dot product, which is 28. So this is how we can perform a dot product, and in our next session we will know about more about why dot product is very important. Yeah, we will know about its generic form and geometric form. Sorry, no, generic form. We will know about its generic form, geometric form. Sorry, geometric form. So let's end our session today, and thank you for staying by until now. And we would surely learn something new in the very session. We'll see how we can represent it, such vectors like sorry, showing you the wrong. So we can simply see representation of such vector, this vector, Then we can also see representation of this vector. We'll also see the representation of unit vector. And also see this one would be the basic one. And also we will see how we can simply do the dot multiplication as well, and in the code as well. And to recap, this is we have learned until today. So we have understood what is a vector. It is a Latin word, and it must consist of magnitude and direction. We can represent it a vector like this, a head and a tail, and magnitude, and why we are learning dot product, what is the purpose of it, and some rules that a vector must obey. And what is an example of vector? I showed you two example, no, two, three, four, five, some less example, but I will try to show you more example in the very next day. And the vector representation of them in a three planes x, y, z, and how we can conclude the magnitude, and how we can know its positional representation here also. And that was, then we know how a scalar matrix can be done, a matrix multiplication of dot product, then the vector multiplication, vector representation, and its dot product. We simply saw how we can get the value of a dot product, or we can achieve the agenda of a dot product in two simple way. The approach one, this one is the approach one, sorry, this one is the approach one, where I did not show you the whole multiplication process, but I showed you the new one, which is very new for you, which is the vector dot product, when I am multiplying two vectors. So multiplying with scalar multiplication of two vectors. So that was our overall session, and we also explored the code, but we did not see pandas because we have a shortened time. So we'll try to cover it in our next day. So thank you for staying until now. Let's try to learn something new in our next session. So thank you everyone for staying until now. We'll see each other again in the next session. And if you have any query, we can talk about it in my DMs, or you can mail me, or you can come to my page and talk about it. So I am open for your question, or if you do not understand a certain point, if you do not understand my explanation, you can also ask me anytime. I'll try to get back to you as soon as possible. So thank you everyone. That would be all for today.